In the top 1000 open source Java repositories on GitHub, we found a total of 690 XXE problems. That is a lot of problems to triage, and they are probably not all true positives. But one thing is very clear: getting XML security right in Java is not easy. The XML standard has been around for a while, and so has Java. As a result, parsing XML in Java can get pretty confusing. This is mostly due to the many available security features, their inconsistency in availability and behavior for these various parsers. I recently wrote a blog post about this topic, and my advice was to use a cheat sheet or a tool like Semgrep to help you correctly configure your parser. Today, I'll take one of the examples from the cheat sheet in the Semgrep docs and show you how to write a rule for it. In particular, we will be using a powerful feature called Taint labels to write a rule that prevents XXE vulnerabilities in document builders. I have already written some test code to demonstrate our insecure code. We will assume for this exercise that the HTTP servlet request is the source of user input. If you are using a different framework or a different library, you may need to change your rule and the patterns you are writing. In this test code, we are creating a file based on this user input. We are instantiating a document builder factory and then using the default configuration of this factory to create a new document builder. Finally, we are parsing the file defined by user input with this document builder. If we take a look at the cheat sheet, the XXE cheat sheet on the Semgrep docs, we can scroll down to document builder factory. Here there's an overview of 10 different payloads, and we've tested all kinds of different configurations to see if these payloads resulted in a successful attack or not. As you can see, the default configuration is insecure for 4 payloads, but luckily there are a few other configurations that we can use to secure our document builder factory. We can use feature secure processing, which is secure across the board. We can also use access external DTT. We can use disallow doc type declaration. And finally, we can combine external general entities with external parameter entities. As you can see, for each of the payloads, there is at least one of these two that is securing against the payload. So in my test code, I have all of these enabled. We have feature secure processing here, and our test syntax says this should not be flagged. We have external DTT here. We have disallow doc type declaration here. And then finally, we have the two different orders for general entities and parameter entities, and here the opposite, parameter entities and then general entities. So let's start writing a rule. So this type of test code is very suited to use Taint mode. Let's take a look at the Semgrep docs to see how Taint mode works. On the left hand side, click on data flow analysis and then Taint tracking. As you can see, we need to specify mode Taint. And then we need to specify pattern sources and pattern sinks. Optionally, we can also add propagators and sanitizers. Semgrep will then use data flow analysis to verify whether any pattern defined in the sources flows through to any pattern defined in the sinks. If it does, this sink will be marked by the rule. So let's start with a small example. We specify mode Taint. And then we need to add our pattern sources. In our case, the source for Taint is the user input, so the HTTP servlet request. We can use a so-called typed meta variable to define any object that is a HTTP servlet request. And then, in particular, we will be looking at getParameter function calls. Next, we need pattern sinks. And in our case, this is again suitable for a typed meta variable, a document builder object that calls parse. So let's run this rule.
And as you can see, all of our parse functions are being marked.
Actually, let's add another test case. A negative test case, so where we don't use user input to create our file. Instead, let's do new file and use a hard-coded file name .txt. Actually, .xml, that makes more sense. And if we run our rule, this should not be flagged. There we go. So let's change the test syntax to OK. The next step, we want to actually add our security features and make sure that these are no longer flagged. So feature secure processing, for example. And to do this, we can make use of Taint labels. So let's go back to the docs. So these are the docs for Taint labels. So we can add a label to a Taint source like this, and we can have multiple labels. We can have label input and label evil to have multiple sources at the same time. And then we can tell a sink that it requires a certain label. So if we go back to our rule, we can label our current source and label it as input. And then since we want to check if our DocumentBuilder factory is using the default configuration, so we'll add a new label factory with pattern new instance, DocumentBuilder factory.new instance. And so our sink now requires both factory and input. So we require a default configuration and user input to reach this. If we run, you can see that we are flagging still everything that we expect. Then let's actually add a new test case where we are finding a different configuration somewhere else. So let's define our DocumentBuilder factory as get a secure DocumentBuilder factory. And now we expect this to not be flagged anymore. There we go. We are now successfully using Taint labels. Let's add another Taint source for our security features. We'll label it FSP, Feature Secure Processing. And for the patterns, well, let's take a look at the documents because the default behavior of taint tracking is important here. By default, whatever is defined in the pattern sources, its return value is the thing that is tainted. But we can change this behavior with the side effect, sources by side effect. And to do this, we need to add a focus meta variable. And we also need to add the by side effect key. So let me demonstrate this on our rule. In this case, we're looking at the pattern set feature secure processing. This one. And we focus meta variable on our DocumentBuilder factory, DBF, like this. And then we still need to add our by side effect true. This should not change the behavior of our rule yet, because in the pattern sync, we now need to add and not FSP. And as you can see, we have one less test case being marked, which is great. Now let's do this again for our other security features. So we already did feature secure processing. Now let's do access external DTD. Let's label it DTD like this, or DTD. Run. There we go. Let's do this a few more times. We have a few other security features. So one for disallowed doc type declaration and one each for the general entities and the parameter entities. This is the disallow. This is the general entities and param entities. Let's copy paste this code. This general entities over there, and then the parameter entities like that. And now we update our requires. So we require factory input and not FSP or DTT or disallow or general entities and parameter entities. And this should work. Yes, all of our tests are passed. There we go. This is our rule finished.